Hi everyone, good morning, good evening. So today we are we'll start with the discussion of the workload automation observability integration solution that we developed for Splunk. So I will just move on to the first slide. So why observability? So observability is going to help the workload automation administrators and the operators to discover the problems and to fix those problems much faster. Uh, it is not just limited to the workload automation administrators or operators. Can also help the application owners to track their workload, health using these metrics, right? Whatever we develop on the observability, and it provides deeper visibility, which allows users to quickly determine the problems as what has happened in the environment, and to identify the root cause and fix the problems. Yeah. So I will just move on to the next slide to discuss more about observability, and then we'll come back to these slide again. Yeah. So when we talk about observability, first we need to understand the term monitoring and their similarities and differences between monitoring and observability. So these are just explained very generic and in simple terms. So first we will talk about monitoring. So monitoring is a solution that collects and analyzes predetermined data from the endpoints. It helps IT organization to detect and notify problems. So so we are aware of only the certain situations where our applications can go wrong, right? And based on those predetermined situations, we ask the monitoring tool to monitor those specific parameters on specific thresholds and get notified if there are any problems detected by the monitoring tool. So what if there are unknown problems which can cause the application outage, which is not being monitored? Right. So those so all these criteria the unknown problems, so that will be tracked using the observability solutions. Yeah. So using the monitoring tool, we are going to get only limited information, and so hence we cannot rely on the data for deep dive analysis, and we should go back to the multiple systems to analyze and identify the root cause of the problem, right? And as I mentioned, about the unknown problems. So unknown problems leading to application outage cannot be monitored because the teams are not aware of such problems unless they experience it for the first time, right? So some of these, issues are being addressed in the observability tools. So coming back to the observability, so observability is the process of collecting, aggregating, and correlating data from three main pillars, which are going to be logs, metrics, and traces from the endpoints to track the application current state. So logs are, in simple terms, it's nothing but the transactions of events occurring within the system, and the metrics are going to be like a quantitative measurements that offers a snapshot of system's performance over the time, and traces helps to track the flow of request through the various services that might involve part of the application or the distributed application deployment, right? So observability is going to help IT to create a single source of truth in a single location to have bird's eye view of everything happening in the environment, and it's going to give detailed information about the problems uh, so that the IT teams can perform deep dive analysis. So without observability, we cannot achieve effective monitoring, as there could be unknown problems involved in the complex distributed systems architecture. Yeah, and next one. So with data being normalized in the observability, we can create our own dashboards, metrics to visualize the metrics for the business teams to help them to view their application stack health and performance. Yeah, and moving back to the first slide. So why we developed the solution for on-premise environment? So because we have the observability solution currently in place for SaaS W environment. So there was no solutions for the customers using on-premise for both IBM Workload Automation or HW Workload Automation environment. So we had a customer requesting the integration of observability tool with on-premises. So we want to monetize any upcoming opportunities on this space. for this integration with the IBM Workload Automation or HCL Workload Automation. So there will be a base package for customers wanting the observability solution to be implemented for a price. But if the customers are looking for further customization, it can be handled as a separate opportunity. So I will move on to the third slide. So again, here, as I mentioned earlier, so we can use Observability for Splunk to monitor workload automation metrics, the batchman events, audits, logs, etc. So we created seven out of the box dashboards to display WA key metrics on Splunk Enterprise. The first one is WA component health and job metrics, critical job metrics, job events metrics, job stream metrics, audit metrics, cleanup metrics, and the final one is alert metrics. So I'll move on to the next one. So before we talk about the detail about each and every the dashboards that we created, so these are some of the benefits that we are going to get out of the metrics or the dashboards that we created on the Splunk. So some of the key metrics are highlighted here. So the first one is health of the WA components. So using these metrics, we can get status of the agents, including the dynamic agents, FTA broker status, the DB connection status, and the how many users are currently logged onto the console. And the next one is batch workload metrics. So using these metrics, we can analyze the batch trend over the time. So based on the workstations, the folders, or the job status. And the next one is the top events. So we can get top events by error code, workstations, and job streams. So using these metrics, we can analyze and identify where there are more job events occurring on workstations or the job streams, and to take necessary actions and to reduce the job failures. And the next one is health of critical jobs. So these metrics helps us to track the risk of the critical jobs configured in the workload. The next one is audit data, which tracks the user activities. And the next one is something like a custom metrics, so which provides the jobs that are not executed in the previous month. And the final one is the cleanup metrics, so which helps us to identify how many agents are sitting idle without any jobs defined, how many jobs exist without the job streams, how many job streams exist without run cycle. So this will ensure the teams to take decision accordingly. So these are some of the benefits highlighted here, and this is the architecture of the solution. So on the left side, we see the on-premise workload automation. So it can be either the IBM Workload Automation or the HCL Workload Automation infra. On the right side, we see the Splunk Enterprise solution. So on the left side, coming back to the left side, so before we start with installing or the configuration of the Splunk agents, so we need to expose some of the data sources for ingestion of data into Splunk Enterprise. Right? So the first one would be exposing the WA metrics. The next one would be configuring the Bmevents. The third one would be which we are aware, the audit events are generated by default. And the final one is the custom SQL data. So we have created some of the custom SQL jobs. So it generates some of which provides data for to create custom metrics. So these are like 4 data sources that we are using on the workload automation masters. And so once we have these data sources ready, so we can deploy the open source Splunk OTL collector and the Fluentd agent on the master domain manager. So both these agents come as an inbuilt package. So once we deploy, so you will also have another component called receiver, so which is going to contain the Prometheus and Fluentd forward receiver. So using these receiver, it is going to get the WA data from the master domain manager. So once the receiver collects the data, it can forward the data to Splunk Enterprise using HTTP event collector. So before we ask the agents to forward the data to Splunk Enterprise, we should be creating the HTTP event collector token and the necessary index for ingesting the data, whatever we are getting fetching from the workload automation source. So once we have the data inserted on the index, then we can make use of those data to create the metrics of the dashboards. So here we can see, like, we have created the 7 metrics out of the data that are stored in the index. And basically, we packaged all these dashboards as a SPL file, which can be deployed as a package on the customer environment. And moving on to the next slide. So these are some of the scopes and assumptions for this development scope. So the first one is basically the analyzing the requirements and checking for the feasibility, and then preparing the environment. The next one, as I already mentioned, to install and configure Splunk OTL collector agent on the master domain managers and the Fluentd agent, and then exposing the WA metrics. So basically, configuring all the data sources that are required to create necessary dashboards. And then you will have a couple of additional tasks such as like creating save searches, command and script input on Splunk Enterprise to support the dashboards. So these are additional configurations that are required to support the dashboards. And assumptions. So the upload automation environment is one of the following versions. So it can be 9.5, 10.1, 10.1, and it can be running on the on-premises environment. The operating system being Red Hat Enterprise for the Windows platform. Database being any one of these database, DB2, Oracle, or MySQL, and only Splunk OTL collector will be used along with the Fluentd agent. So we developed and tested this particular solution on these components, whatever we have mentioned here. So upload automation being the version 10.1, DB2 11.5, RHEL 8.6, Splunk OTL collector version, and the Fluentd version. So please note, we have not tested this solution using the Splunk Universal or the heavy forwarders agent, and also we have not enabled SSL communication between the components. So these are the assumptions. And moving on to the next slide. Yeah. So this is the first dashboard that we created. So I will just glance all through the slides from here because I'm going to walk through on the Splunk Enterprise console directly. So we'll come back to the PPT after the demo. So just glance once. So yeah, the first one is WA component health and job metrics. So we have some of the metrics published on this dashboard. So the first one is agent link status, agent running status, TV connection status, and the users currently logged on to the console. Moving on to the next one, we have the job status by the pie chart, and so we also have a job count by workstations, job count by folder. So including all the status by each workstations, including all the status by each folders. We also have workstations and the status segregated and their count. Similarly for folder name and for the job status as well. And we have time trend of jobs by workstation, job status, and folder. So the next one is critical job metrics. So we create metrics for to publish total critical jobs, no risk jobs, high risk jobs, potential risk jobs, and also we have the table chart for populating the incomplete producer jobs for the critical jobs. And the third one is job Abend metrics. So these are the metrics part of the job Abend metrics. Top 15 Abends by error code and their list, and we have Abends by hour, and then last 30 days Abends indicator by date and month, and we have last 30 days Abends indicator by day, and then we have Abends by workstation, and then we have Abends by workstation list, and then the next two are the additional metrics. We have the jobs not executed previous month and the number of executions per jobs. The next one is the fourth one is job stream metrics. So we have top 15 Abends by job stream. So we have bar and table chart here. And then the detailed information about the job stream and the job details based on the filters that we have here. And the audit metrics. So the total number of audit events and the audit types, we have 4: plan, stagement, database, and conman, and their list. Similarly, the pie chart for each and every audit types. Similarly, you will get the audit the action type based on the selected users, and also we can try to filter certain objects, and then we can get the data. Yeah. And then we have cleanup metrics. So here we have captured agents without jobs and their list, job stream without run cycle, jobs without job stream and their list. And then we have finally alert metrics. So we have created like 4 category: critical, high, medium, low, and the following 2 pie charts represents alert page severity and alert severity. Yeah, the first table chart represents what are the alerts that we have configured and enabled in the environment, and the second table represents what are the alerts that are triggered based on the time and the name severity. So now I will move on to Splunk Enterprise console. So this is the homepage of the console. So where we have created this solution as a separate package. So this is the application IWA-demo. Yeah. So this is the first dashboard. So we have these are the metrics part of this dashboard. So the first one is agent link status. So I will get all the agents from the from the installation, and so you will see the status. If the link is down, you will see like link down on the right, and if it is up, you'll see like link up. So similarly, you will see the agent running status with the agent name and the status, whether it is in stopped or running status. So we'll also see the DB connection status, which is success or failure, and how many users are currently logged onto the console. Yeah. So we have the job count by status, basically the pie chart. So here we have like 3 filters. One is workstation, job status, and folder. And so when I try to filter for any particular workstation, say for example I use DI filters. So this filter will fetch only this particular workstation on this tab, and the total number of jobs irrespective of the status for this particular workstation, and the percentage. And similarly, when you filter here, and so we'll also get this filter working here, job count by workstation status. So you'll see only the agent name selected there, and with all the status. And coming back to the trend of jumps by workstation. So since I have selected the filter, I'm seeing only the the workstation here, DI test. So here we highlighted only the the low value and higher value. So now I will remove this filter. So you'll get all the workstations and status. So here you can see all these workstations being mentioned here. So you can just hover on the workstation name, and we can get the the graph. Similarly, we can try to filter for job status, and similarly we can try to filter for the folder status as well. Moving on to the next one, critical job metrics. Yeah, so these are the total number of critical jobs in the configured environment. So we are getting 4, and the list of the critical jobs here. So and currently we have no risk jobs, and everything is on the high risk jobs. So you get all this data in the high risk jobs. And since it's only 4, and the count is 4 on high risk jobs, so we don't have anything on the potential risk jobs to report. And we have one other filter, so where we can make use of this filter to get to know the list of incomplete producer jobs for any critical job. So you can use this filter to select and see how many incomplete potential jobs for that particular critical job. And moving on to the next one, job Abend Metrics. So top 15 Abends we have code pie chart. So this is only showing for the percentage based on the error code, and this is the list, and also the total of those error codes. And the next one is Abends by hour. So it will report only for last 24 hours. For each and every hour, so we'll get the count of the job opens. So the next metrics is related to last 30 days metrics related to job opens. That is indicated by the date and the month. So last 30 days we can find the data for here. So the next one is just the duplication of the above one, but it is represented in a different format. And yeah, the next matrix is Abend's workstation. Yeah, yeah, the workstations will be reported here based on the job events. So we have like 2 workstations and their job events count and their list here. And these are the additional metrics. So which is coming out of custom SQL jobs. Yeah, and so what are the jobs that were not executed previous month? It will be reported here. Similarly, we have the other metrics which is coming out of the custom SQL. So where we have the number of execution per jobs. So we have like job name, workstation name, and how many successful runs are there, and how many abandoned runs for the selected time interval. Moving on to the next one, job stream metrics. So here we have the top 15 job stream events and their job opens count, and their the list and the count. So here we have 2 filters. So I can choose either of the one. For example, I can choose something like final here, and I can see even though it says completed here, I can see its intro on the make plan because of the BM events, the recycle, which did not track this event. Probably I can just say the final report, final post reports. No. So when you choose the final post report from the filter, so you'll get the status of the job stream here, and also in the below table chart, you will get the status of all the jobs part of the job stream. So you can also filter by the workstation name also for the job stream details and job details. So moving on to the next one, audit metrics. So in last 24 hours, there are like total number of audits is 229, and so we have the pie charts based on for the audit types, and we have the list along with the total and the percentage, and these are the individual pie chart for the audit types that we see here. And since I have like only user, I'm seeing only HCL user here. So if you have like multiple users, you can select multiple users, and we can get to know what action type and audit type the user is performing. Similarly, we have the IW objects here, so we can select any objects here, and we can try to filter, and we can see which user is performed what action. The action command is there, and what time the user is performed that action. So we can get those details from here. So coming to the cleanup metrics. So all these metrics are coming from the custom SQL. So these are some of the these are all the list of agents that does not have any jobs defined. So based on this, we can try to check and if it is unwanted, probably we can try to remove from the environment, or we can reshuffle the job definition based on the metrics. The next one is job stream without run cycle. So there are like 20 job streams that are defined without any run cycle, and they are listed here. Similarly, the jobs that are defined without any job stream. Maybe these are like on-demand jobs. So looking at the list, people can decide if the jobs are required, or it can be removed from the environment. And coming to the last metric, select metrics. So we have critical, high, medium, and low. So first, I'll go through it. So these are the alerts that we created and enabled. So we can also try to filter based on alert severity, and we can also try to select based on the status. So it is enabled. So I'm saying agent link status, agent running, broker status, DB connected, master available. Okay. So master available, we are monitoring for the API URL. If it is down, we will get the alert. So similarly, DB connection, we are getting through the IWM metrics itself. So all these I know from the IWM metrics, all these first four. Yeah. So yeah, and these two pie charts, so basically the alerts, categorized by the severity, and similarly, like it's categorized by the alert name, agent link status, agent running, UI available, and master available. These are the four alerts that were triggered in last 24 hours. And, so we can see, at what time the alert has been triggered and what severity it is. Yeah, so we can also filter here to see which one is medium and what is the alert name. I don't think there is any data there. I think, yeah, probably I need to check this filter if it is configured properly. Yeah. Yeah. So going back to the presentation. Yeah, so these are some of the important useful links for which we used for developing these solutions. We can refer these URLs.